Okay, so let's start now the actual programming parts for this week. So indeed, now you got a quite nice introduction from Geoff about different capabilities of this OSMNX package that we are going to learn to use a bit. There are a lot of good examples actually available from this GitHub repository of this OSMNX package to, for example, show how Geoff have done those nice maps dealing with kind of the structure of the cities, but also showing kind of those orientation plots. So if you're interested, you can actually take a look of how those things can be done using OSMNX package and some matplotlib things basically. But our focus in the lesson part will be mainly kind of first of all see how we can fetch or retrieve different kind of data from OpenStreetMap directly in Python. And then we will explore a bit how to do network analysis in Python using OSMNX package to retrieve the data, and then a package called NetworkX to actually do the routings. So those will be the topics for today. Let's try to, I need to leave today a bit early because I have an event where I need to speak later, starting at 12. So let's try to keep the schedule tight in a way that we can manage to go through all the stuff. Yes, but let's start from the first topic. So indeed, now the idea is that we will use, I will launch the student binder here while I'm explaining. So we will use OpenStreetMap data today quite extensively. Is OpenStreetMap familiar for all of you? Is there someone who doesn't know anything about OpenStreetMap? Good. So that's good. So we don't need to use too much time kind of about using or introducing the OpenStreetMap. But basically it is this kind of a collaborative crowdsourced data set, kind of Wikipedia of maps where everyone can basically go and edit and improve the data set. And kind of map the world. And there is a huge amount of users, so there is basically more than 4 million users in using OpenStreetMap, and then there is over 1 million contributors who are actually digitizing stuff into OpenStreetMap. And there is also quite nice projects have developed around OpenStreetMap, such as this humanitarian OpenStreetMap project HotOSM, which is basically kind of projects and these kind of hackathons that aim at helping catastrophic areas, for example, to digitize the environment after, for example, if an earthquake has happened and so on. So these kind of events are happening all over the world, also in Finland. Has someone been part of these HotOSM hackathons? Yeah, a couple of you. So this is kind of really nice project, kind of helping out people and countries and areas having difficulties. So that's about it. But then indeed, so we are going to now explore the functionalities of this OSMNX package that was indeed developed by Geoff first for his PhD thesis, but now it has kind of started to evolve into kind of one of the main packages to even for retrieving OSM data and doing urban analytics. So it's quite a nice package. But let's start by seeing how we can actually now use this OSMNX package. There is, by the way, if you're interested in more, so there is quite a bunch of papers published by Geoff. This is the one he has where he introduces this package on this scientific journal, Computers, Environment and Urban System, if you're interested. But how we will now start is that we will see how we can retrieve data. Well, we will now take an example from here from Helsinki, so we will see how we can fetch data from Kamppi, which is a kind of a small area in the city center. And what this OSMNX package actually uses to fetch the data is that it uses this Overpass API. So this is a bit of similar thing that we already used the Nominatim API to actually geocode locations. So if you have addresses, so to understand where those locations are. So this is another API kind of built on top of OpenStreetMap that can be used to fetch data from there. If you're otherwise interested in OpenStreetMap data, there is this geofabric.de, download.geofabric.de. So this is a location if you're interested, for example, to download the whole OpenStreetMap for the whole world, which is a huge chunk of data. Or if you're interested in, for example, getting the data for whole Europe or specific countries. So this download.geofabric.de is a kind of web page where you can fetch the data in different formats. There are a couple of different formats that they are usually distributed. One is this protobuf format of data, which is a compressed data structure having the OpenStreetMap features, but then there is more maybe kind of familiar format to use the shape files that you can also download from here. But this is a good site to remember if you're interested in, for example, downloading huge data sets of OpenStreetMap. So I wouldn't recommend maybe to especially fetch, for example, using OSMNX the whole Europe of data with from OpenStreetMap, because it will take a long time, and it's much better actually to take a dump which is compressed from here than to actually kind of use the API, because there is a lot of people using the API, so we don't want to kind of start limiting or putting too much pressure on the API. But this here, okay. But let's start checking out the OSMNX package. So we have the packages installed on the instances. So the first thing, of course, again, is that we want to import the OSMNX package that we are going to use. And quite typically, as in other packages as well, so we want to give a shorter name to this package. And this OX is a typical way to kind of shorten the package name of OSMNX. Let's also import matplotlib.pyplot as PLT, and then we do the typical trick inside the notebooks is that we use the magic command matplotlib inline. So there are different ways how you can fetch data using OSMNX package, and one of the easiest one is that you can just specify a place name that you are interested in. So let's specify the kind of criteria. So specify the place name, and let's say that we are interested in getting data from Kamppi, Helsinki, Finland. And now thinking of these addresses in here, so OSMNX is using Nominatim as a API background service for fetching the addresses. So again, in a similar manner as with the geocoding part. So if you want to know what is actually certain address giving you, it is good to go to the nominatim.openstreetmap.org and see, for example, that what Kamppi, Helsinki, Finland is giving us. So as we can see, we should get something like this as a result when we are using the OSMNX. So kind of data from this area here. Good. But then, so let's fetch OpenStreetMap street network from the location. So let's create a variable called graph. So basically what we are getting is a network, which is a kind of graph. And from this OX package, we have a function called graph from place. And this is a function that we can basically use to assign the place name as a parameter to this one. And let's check when we have fetched that, what is the type of it. So now when we execute the thing, place name. So now when we execute this cell, what it will do is that it starts to use the overpass API. It first uses the Nominatim to actually understand the location boundaries, and then it fetches the graph from that area. And now what we can see, that what we got out, so the type of that is actually from this NetworkX package, an object called Multicraft. And basically what this is, it's kind of a, let's go and check NetworkX. So this NetworkX is indeed another Python library that can be used to do all sorts of network analysis. And OSMNX package is kind of using also our build on partially on top of this as well to understand different kind of attributes from the networks. But the Multicraft indeed is an object from this NetworkX library, and it basically represents, it's an object that represents a network where you have nodes and you have edges and you have some kind of attributes associated with those nodes and edges. So typically what you have is, for example, in OpenStreetMap, so you have information about what is the length of certain road segment, for example. And then you have information about the coordinates of the nodes, and you have typically some kind of ID associated with it. And this NetworkX indeed can be used to, for example, calculate shortest paths. So doing these kind of routing operations using Dijkstra's algorithm or A-star algorithm. We will go through those things better on the next tutorial. But let's now see a bit what do we actually have in here. So of course when you have some data, you most probably you want to plot it. So let's plot the data that we have in here. And what this, so OSMNX actually contains a nice function to really easily plot the graph that you get. So there is this ox.plot graph. And then what it wants as an input parameter is the graph that we fetched from the OSM database. And when we do this, we actually start seeing that, okay, we indeed now have some data retrieved from the area that looks quite similar to this one. So what we can see here is that we have now different kind of edges. So these road segments are the edges in here, and then we have nodes that are visible with this blue color. So they are kind of the intersections of the streets, for example. So this is what we have from there. It's also possible. So this is now the network data that we fetched, but there is possibilities to fetch also other kind of data from OpenStreetMap, such as the kind of footprint of the area, buildings, and also, for example, points of interest. So let's see first how we can actually retrieve the footprint of this area. So if you want to understand, for example, the extent of different neighborhoods or extent of cities and so on, so of course you might use other data sources, but OpenStreetMap is quite handy data set to fetch that kind of information. And indeed OSM and NEX can be used quite easily to understand, for example, what are the boundaries of Finland or Sweden or any other kind of administrative area. But now let's retrieve the footprint of Kamppi. So we can say that area equals to OX, and then there is this function called GDF, so geodata frame from place. And again, what this wants as an input parameter is the place name, so the address that we specified in the beginning. So Kamppi, Helsinki, Finland as text. So let's take that one, and actually let's see how does it looks like. OX.plot. Oh yeah, but this is actually, so if we take a look what we have in here, type area. So as we can see, this is now a geodata frame that we have in here. So we can just use typical geodata frame objects to understand, and we can see that now we have kind of the footprint of that area that we were interested in. Let's also retrieve buildings from the area. So I will call buildings equals to OX dot, and then there's this buildings from place. There is actually, as you can see from this list now, there are also other functions that can be used to fetch the area. So not only the address is the only possible one, or the place in here, but you can also specify a point and distance basically from that point that you want to retrieve the data, or you can pass in your own polygon as well. So if you have some specific criteria or specific area of interest of your own that where you want to fetch the data, you can use that function to pass it in, and then it will collect all the data from using that polygon, for example. But we will use again this buildings from place function. So following the same idea as before, so we just specify the place name in here, and let's do this. Yes, kiitos. Typo. So buildings from place. And now we should have some buildings. And what we see from here is that we indeed now have all the footprints of each of the buildings that has been digitized in OpenStreetMap. And of course, thinking of any kind of urban analysis, you might already kind of do quite cool things with this kind of information. For example, understand the density of housing in different areas just by fetching the data, using the area and combining like what is the footprint of the buildings compared to the whole area of that area of the area of interest to see this kind of density things. But then actually let's take a look. Buildings.head. Let's take a look of what kind of attributes we have. So of course, OpenStreetMap is not only about the geometries, but also about all different things that are kind of information that is associated with the geometries. So here, for example, in the buildings, we have a lot of kind of attributes that are available. So for example, we have information about the actual address of that location, house number, postal code, the city and the country. Then if the building is, for example, Lasi Palatsi seems to be one of the rows in here. So you might have some links to the actual websites of those things. And lots of other information. So what kind of attributes are available? It's basically about the quality of the OSM data. So it's just that if people are kind of contributing to the OpenStreetMap, updating the data, so it will be available. But of course, the quality of the data, it can be it might differ a lot depending on the area where you are looking at. In Europe, for example, in Helsinki, so the quality of the data is quite good because we have so active kind of user base contributing to the data. But yeah, so you can get kind of nice attributes out from here as well. But then there is the possibility to fetch also points of interest from the OpenStreetMap data. So let's see how we can retrieve specific amenity from OpenStreetMap. So if I Google StreetMap amenity, so these amenities are basically different kind of services that have been added to OpenStreetMap. They can be, for example, well, bars, beer garden, cafe, restaurants, and all sorts of things. Well, schools like education, things like college, libraries, and so on. And there is a long list of different kind of attributes that can be fetched from the OpenStreetMap. So let's see how we can actually use this amenity key and retrieve restaurants from Kamppi. So let's create a variable called restaurants, and this equals to ox dot poise from place. And again, we pass in the place name. So this is the kind of name that we defined in the beginning. But then there is a parameter called amenities. And this is basically a parameter that you can pass and use to pass a list of such amenities that you are interested in. And what these are, they are basically the keys that are listed on this web page. So if we would be interested in seeing what kind of bars are located in this area, we could pass in this bar text in there. But because we are interested in the restaurants, so we will add this restaurant thingy in here. Oops. So restaurant. So this is how we can fetch the restaurants, and we can, for example, take a look how many restaurants can be found from this area based on OpenStreetMap data. And it seems that we have 199 restaurants in here. Let's take a look at again a bit of what kind of data do we actually have in here. So the restaurants is, again, it's a geodata frame that we get from there. And again, we have similar kind of attributes that what we saw with buildings. So we have a lot of information about, well, the addresses, even if there are toilets available that are wheelchair accessible, and so on, about websites and so on. So there is a kind of useful information available. There should be also, oh yeah, let's take a look of the columns. So this is the full list of things. So we just saw now a couple of the attributes. So we have a lot of information about, for example, the contact information. What else could be useful? There is opening hours, for example. Yeah, and lots of different attributes. So kind of using this this data, you can already do quite neat things in terms of understanding how different services are accessible, for example, at different times of the day. If we have information about the opening hours, and then we know, for example, travel times to that location. Good. Let's let's select a few of the attributes, because we won't be needing all of these. I don't even know how many there are, but quite many attributes. So let's select a few of them. So, or actually, I will just show from here. We don't need to do that. But this is how the data. So in here we have selected few of these things. So for example, when looking at the opening hours, we can see that you might have this kind of information. You have the name of the restaurant, for example. So this seems to be a restaurant called Kapuki, and then there are the other ones. Papa Albert seems to be open from Monday to Thursday, from 10 to 2, and then from 5:30 to 10 in the evening, and so on. But yeah, so that was maybe the point of looking at that. But let's finally, so the idea is that let's plot all of these things together, and let's see how we can actually, because now what we have in here, so this graph is actually, as we found out in the beginning, it's this kind of multi-graph from NetworkX. So if we want to, for example, use GeoPandas functionalities to analyze, for example, that network, we need to actually convert this graph first to geodata frame. So let's see how we can how we can do that. So in OSMNX package, there is a function called graph to GDFS. So let's convert graph into geodata frame. So indeed there is this OX dot graph to GDFS. So what this graph does, this function does, is that it, well, first of all, it wants to have the graph that we fetched from OpenStreetMap as an input. And what it returns is that it returns nodes and then it returns edges. So if we think about how graph is built, so indeed it consists of the edges, so the links between intersections, for example, and then those nodes that are actually the locations where intersections are located. So it kind of includes information about two different data sets in a way, and that's the reason why we actually get two different data frames out from here. And let's see what when we execute this. I will move this in here. So now we can take a look what is the type of the nodes. So indeed now it's a geodata frame. We can plot it, for example, to see that okay, we have these lots of points in here, and then we have the same thing with the edges. So now we have a geodata frame of that, and let's take a look what kind of attributes do we have. So now what we can see is that also the street network contains quite a bit of information that can be useful. We have information about, well, first of all, the geometry of that street. Then we have this tag highway, basically describing what kind of road that is. Is it a residential road? Is it a footway? For example, is it a motorway? And different kind of tags specifying the road class of that road. Then there is possibly information about how many lanes there are, possibly information what is the maximum speed, so what is the speed limit on that road, and then also what is the length of that road in meters. So this kind of information we can get directly from the graph itself. So let's finally kind of make a map with all these different data sets that we have now retrieved. So we have the footprint, we have the road network, then we have the buildings, and then we have actually restaurants. So we can get already quite a bit of information out of a certain area with these 4 layers. So let's first plot the footprint. So, and we are now using the typical GeoPandas plotting functionalities to do these things. So we can say that area.plot, and let's say that the face color, so what color of that polygon will be black. And let's plot on top of this one the streets. So the streets are basically the edges that we have in here. So let's plot the edges dot plot, and now we are plotting into the same on top of this footprint. So we specify x equals to x, and let's say that the line width of the road should be 1, and let's specify that the edge color. So what will be the color of those lines, those streets that we are specifying here? And let's specify this hex code PC8F8. F. So these hex codes are useful to specify the colors, and if you haven't used and seen those, so there is, for example, if you Google just RGB color, so there is, for example, this kind of web page where you can try out all different colors, and here you will see what is the hex code actually of this specific color, for example. So it's easy to copy and paste from this this website this information. So RGB color should basically kind of the first link, at least on my Google, is this one. I don't know how much Google has kind of personalized my searches, but anyway, that's at least what I get. Good. So now we have the edges with certain edge color. Let's finally plot buildings. Again, let's say that x equals to buildings dot plot, and specify that x equals to x. So we are again plotting on top of each other these things, and let's put a color called khaki as this one, and let's put some transparency into this one. So let's put alpha equals to 0.7, and the final thing is how to plot the restaurants. So we can say that x equals to restaurants dot plot, and the same stuff, x equals x, color will be green. Let's put some transparency in here as well, 0.7, and let's specify that the marker size of that point will be 10 units. So now we have these 4 different layers. We don't have the nodes, but we don't need to worry about those. And now I have some typo somewhere. Where is it? Okay, yes, typical line width. It's always incorrect order. But now, as a result, we get this kind of map that looks quite similar to what we have on the web page, where we have the streets, we have the buildings footprint, and some of the restaurants are located in the area. So that's kind of the first steps what we can do with this OSMNX package. So as you can see, it's really easy to fetch data using this package. Do you have any questions at this point about these things?